Okay, so which chapter do you find the hardest in science? Okay, that's what I was planning on starting with. Okay? Okay, so let me ask you some questions just to see where you are. This is not like a judgment or anything, so that I know how much I need to teach you, right? Okay, what is a combustion reaction? Who can answer? One at a time. What is a combustion reaction? Nobody? No? In the presence of air. So burning anything in the presence of air or oxygen is combustion, right? Okay. And what is ethanoic acid? What's the chemical formula of ethanoic acid? CH3COOH. What is the type of bonding that is present in SiO2? Okay. So you do have somewhat of an idea. So I'll start from the beginning and I'll tell you how to study this chapter before I actually teach this, okay? So this chapter, this is carbon chemistry. Okay? So mainly this chapter in your textbook is divided to its physical properties and chemical properties. What's the difference between the two? So when you talk about physical properties of carbon, you're talking about what are the boiling point, what is the melting point, what does it look like, what is its shape, what does it smell, and also about the bonding, like what type of bond it is. But in chemical, you're talking about what type of reactions it undergoes. So what happens when you put a carbon compound with something else and all that, okay? So the first part of your chapter is explaining all the physical compounds, right? So you already told me that the bonding is covalent bonding. What is the other type of bonding that you do? Ionic bonding. Okay. So can you differentiate? What's the main difference between ionic bonds and covalent bonds? One at a time. Who wants to answer? Put up your hands. Why don't you do that? Everyone's answering, so okay, you tell me. Yeah.
In covalent bonding, we'll be sharing electrons.
Yes, you'll be sharing electrons, right?
In ionic bond, we'll be sharing completely.
No, okay.
Not sharing.
When you share completely, what does that mean? When you share something completely with me, what are you doing? You're giving it to me. Yes, transferring, right? So, sit down. What's your name?
Zain.
Zain? Okay. Okay, got it. Okay, so say there's an oxygen and there's a hydrogen, right? If this oxygen is completely giving one of its electron here, and so when you lose an electron, what charge will this get? Positive. Okay, this is not correct, okay? I'm just randomly using some letters. So this will be positive because it lost something that has a negative charge. When this one gains something that has a negative charge, what does this become? Negative. Okay. Actually, this is wrong. It's always O minus and H plus, okay? So in a covalent bond, you cannot find anything that is completely positive or completely negative because electrons are not being exchanged. So here what actually happens is when you have an OH bond, one electron from oxygen and one electron from hydrogen is being used by both. So 1, 2, 3, 4, 5, 6. Yeah. So oxygen has 7 electrons around it, and is sharing this one from hydrogen. So totally it has 8 electrons. And how many does hydrogen have totally? 2. By itself it only has 1, but since it's sharing one with oxygen, it has 2. So 2 electrons. So both of these are stable, right? Okay. So if you have one thing that's positive, if you have exchange of electrons, what can it do? Like, can it conduct electricity or not?
No.
Something. Yes or no? See, electrons are moving from one atom to another. Can you conduct electricity or not?
Yes.
Yes, because what are electrons? Electrons are charge carriers. So if the charge carriers are moving, they can move current, right? So that's why ionic compounds are good conductors of electricity, covalent compounds are not. So are organic compounds or carbon compounds good conductors of electricity? No, they're not. And also, which one is... So when you have one positive and one negative completely, the force of attraction is really very strong. So when it's strong, can you break it easily? So what exactly are you doing when you're making a solid to liquid? You're breaking bonds, right? You're breaking certain bonds. And if the bonding is very strong, you cannot break bonds easily, because of which you need a very higher temperature. So that's why. So what are the properties of carbon compounds? They have high melting point, boiling point. They are not good conductors. You know the reason, right? So what else?
So they're soluble.
They are
Soluble in water.
soluble in organic solvents, right? So do you think an organic compound is soluble in water? Is water organic? Water. What is water? Can you see carbon and hydrogen? It's not a carbon compound. Okay. This is polar. Water is polar. Are carbon compound is water a good organic solvent? No, it cannot. Why? Because the bonding in this is different from the bonding in carbon compounds. But okay, what's alcohol then? What is alcohol? Is it an organic compound? Yes, right? Which is a common alcohol you know? Common from your textbook. Ethanol. What's ethanol? Right. So I just told you that organic compounds are not soluble in water, but ethanol is. What? Why? Okay, so you have learned the other chapter, right? Periodic properties. So you know what's electronegativity. So here actually what's happening. Do you know what are hydrogen bonds? So usually the general thing is like dissolves like. So if I'm a polar solute, a polar solute will dissolve in a polar solvent. But you can sometimes make some of these organic solutes soluble in water because it can form hydrogen bonds with water. That is the reasoning. So you know what happens here? So imagine I'm putting alcohol in water, okay? So I have a big compound like this, right? CH3, CH2OH. This is your ethanol. And then I have water. The water? So what is the special property of oxygen from your other chapter? Periodic properties of elements. Oxygen. Valency? Valency is 2, yes, that's right. But what does it make oxygen? Is oxygen small? Oxygen is small. Its valency is also lesser. So what does it tend to do? It tends to take in electrons. That means its electronegativity is? Electronegativity is high or low? What does electronegativity mean? Tendency to attract electrons. So oxygen, 1, 2, this is the outermost shell only, okay? 1, 2, 3, 4, 5, 6. So it already has 6 protons and it has 6 electrons. So what does oxygen try to do? It's very small, right? So obviously the nucleus is very close to this electron. 2, 3, 4, 5, 6, yeah. So this is very close to, so the nucleus is here and the ring outside it is very, very close. So it can easily take in 2 electrons more, which is why its electronegativity is very high. So, and what about hydrogen? Hydrogen tends to be easily positive. So what happens is when you put, say, a drop of ethanol into water, 1 drop of ethanol has so many molecules, right? So each molecule, 1 oxygen that's highly electronegative, can slowly attract this hydrogen to itself. It's not a permanent bond. It's transient. Transient is temporary. So if I move it around, So if I like swirl the bottle, what can happen is this hydrogen bond can break and you can form a new one. Right? So these are all permanent bonds. These are bonds that you cannot easily break. But these type of bonds you can break by physical activity. And this is what you do when you're boiling. What do you do to water when you boil? So many hydrogen you have bonds like this. When you boil, you're trying to break these bonds. So it comes apart. That's what you're doing here too. So this bond forms when you put ethanol in water, and that is why ethanol is soluble in water. Okay? Anything to determine any physical property of any element that you're learning, the first thing you need to know is its valency. Why did this happen? It happened only because of the valency of oxygen. So tell me another element that can form a hydrogen bond. No, so I told you something that's high in electronegativity can form a hydrogen bond, right? Because when you're so very negative, you can attract something that's positive. If I'm only a little bit negative, I'm not negative enough to attract someone else. But when I'm super negative, I can, attract something else. So what is more electronegative than oxygen?
Fluorine.
Fluorine, good. So fluorine is something that can form. So hydrogen fluoride is an acid, and its melting point is high because it forms hydrogen bonds, right? Okay. So, but is carbon electronegative enough? So, okay, always when you study chemistry, you should have a good idea of the periodic table. Do you or do you not? You do, okay. So, this is your first group, second group. This one, you don't have to worry about, okay? Don't worry about this until like grade 12 or something. This part. Then you have your bigger chunk, right? Group 13, 14, 15, 16, 17, and 18. Okay, we don't have to worry about anything at the bottom. We are only dealing with the first 20. It will be good if you know the first 20 elements by heart. So, where do I start with?
Hydrogen.
Hydrogen.
Helium.
Okay, good.
Helium. Beryllium. Boron. Carbon. Nitrogen. Oxygen. Fluorine. Neon. Sodium.
Here?
Neon.
Okay.
Sodium. Magnesium. Aluminium.
Yes?
Silicon. Phosphorus. Sulfur. Fluorine. Argon.
Argon, and then just note here too.
Potassium.
And?
Potassium.
No, tell me. Okay, if you know this much, you're good. Okay? So, what's the valency here? Okay, what charge does group 1 for? Positive 1, right? So you go positive 1, here what happens? Positive 2, here what happens? 3. And what about, okay, now what about here? Okay, here, okay, let's wait for carbon, and then what happens here? Negative? Okay, leave carbon. Next. Negative 3 here, okay? Okay, noble gas, no, goes like this. 1, 2, 3, then we don't know what's happening here. 3, 2, 1. Right? Isn't this what's happening? Why? So, even though, actually, okay, what's the difference between valence electrons and valency?
Valence electrons is the number of electrons.
Number of electrons in the valence shell is valency. So, oxygen's valence electrons are 6, but its valency is 2. So, but in the first 1, 2, and 3, in these 3, the number of valence electrons and its valency is the same. But here it's different because, okay, here you can say that number of valence electrons, well, when I'm talking about carbon, what's the valence electrons of carbon? 4. So do you lose 4? So carbon can do 2 things. It can lose 4. So what? If it loses 4, what will it become? Right? If it, okay, loses 4 electrons. And in carbon, what can it do? Are these two possible?
No.
Why? Why is this not possible?
Because if it gains 4 electrons, it will be too heavier. If it loses 4 electrons, it will be too lighter. It cannot exist.
Yeah, but what do you mean by too heavy and too light? This is one thing. When you answer questions in an exam, the words that you use should make sense. Like, it's not enough that it makes sense to you. Someone reading it should understand what you're saying. And what you said, I know where you're going. You said that it's heavy and it's light, but heavy, do you mean the weight will be heavy?
No, it cannot exist in that form.
Exactly, then that's what you need to write. You cannot write the answer that is heavy. So if you write something like that, you're not going to get the marks. Okay, because even though you know the answer, you will still be wrong. And then you're going to sit here and wonder, I answered it right, why did I not get the points? Because you didn't use the right words. That's why you need a little bit of memorizing along with understanding. First step to studying, understand the concepts. But after you understand, if you have trouble phrasing the answers properly, you have to memorize a little bit. Everyone says, okay, don't memorize, understand. That's true, but after you understand, a little bit of memorizing will help you do really well. That's the, one extra thing you need to do. Don't memorize without understanding. Understand first and then memorize, okay? So, why cannot it accommodate? So, carbon has a nucleus that has how many protons? 6 protons, right? Because dynamo shell has 2. 6 protons. So, imagine 6 protons attracting just 2 electrons. It's not feasible, right? So, the thing is, here it says that if you have to remove these 4 electrons from something that has 6 protons, it will not let you do that. Okay, maybe you can remove the first one. When you remove the first one, what happens? You have 6 protons holding onto 5 electrons. Fine, you can remove 1 more. You have 6 protons holding onto 4 electrons. But imagine you having 6, so already this nucleus is lacking electron. It's not going to let you take any more. So no other element that we have found so far has enough, the potential to take out that 3rd or 4th electron from this. That's why this is not possible, okay? Now this one is not possible because here, if I have to gain 4 electrons, the 6 proton nucleus has to hold on to 10 electrons. This is not positive enough to accommodate these many negative charges, and this is why it's not possible. So the carbon came to a solution where it shares electrons, and that's where covalent bonding became a thing, okay? Explain the, the electron dot structures. Azra, can you do it?
Carbon.
Yeah, you can choose any carbon, just explain the electron dot structures where, okay. Explain bonding in 2 oxygen molecules. Yeah. Everybody can try it. Try it yourself. I want you to explain it as you speak, as you do it, so that I know whether you're using the right words or not.
So oxygen has 8 electrons totally, and
Explain to the class. I know.
and its valency is 6. So it should attain 2 more electrons. It should gain 2 more electrons.
Yes.
So yeah.
Yeah. Go ahead.
It forms covalent compound.
Right. So, no question here. Okay, what you did is right. So this one has, according to what this picture, okay, move so that everyone can see. How many electrons is one? Okay, now I'm considering this one. Okay, when you draw a line like this between 2 molecules, 2 elements, see, okay? How many electrons are there in a bond? One bond means how many electrons? 2 electrons, right? So now from what you drew, I'm looking at 1 oxygen, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that correct? Okay, so you get what's the mistake? Okay, fix it. So at first, draw the molecule. So we're talking about oxygen here. So we have 1, 2, 3, 4, 5, 6. Okay? Obviously, you're drawing with a pencil, right? Never draw pictures with a pen. Right? So now I know. See, I cannot. So this is already all the electrons that both the oxygen has Both the oxygen atoms, I've already drawn that. I cannot draw any more electrons, right? Can I draw or not? So when I put a bond here, that means I drew 4 extra electrons. They don't exist. I cannot bring in electrons that don't exist. So what I can do, so I can look at this and I can say, this one needs 2 electrons. This one also needs 2 electrons. That means I have to share 2 each. So I'm going to erase 1 pair from this, put it here. Erase 1 pair from this, put it here, and make a bond among the 2. You can only make bonds among between existing electrons, okay? This is how you do it. So, next one, I'm pretty sure you should know this by now, methane. Can you do methane for me? What's your name?
Roshan.
Okay, come on. I want you to explain it as you do it. Draw the structure, and as you're drawing, you have to explain to me what you're drawing. Everyone needs to try that. Methane. That's fine. How many does carbon need around itself? 8. No, it has 4, but it needs 8. And I already made it, right? So here, these are the 4 of the carbon, and these are the 4 from the hydrogens. So carbon exists like this. So I make a circle here. Now hydrogen requires 2, so I make a circle here. So basically what these circles in your textbook mean is that inside one particular circle, that will have all the electrons that belongs to the element in the circle. So if you make it like that, so when you answer, try to answer it like the way it's given in the textbook. It's not like you don't have to force yourself to form a different method or anything. It's all the same. If you can understand one method, you should be able to understand the other one. So if you can draw this, because when someone corrects your paper, if they see something that's very similar to your textbook, they're not going to have to look again. So they'll just give you the points. But if they feel like, okay, what is this, and they have to figure out and they're tired and they just don't give you the points. And you don't want to risk it, right? Okay, good. So now, carbon. Why? So you have how many elements? 118? Why is that carbon has a chapter for itself? Why is carbon special? Yes, basically, there's a statement here that says, the number of carbon compounds that we know so far is around 3 million. And we don't know any more, element or any compounds that exist that's made of another material other than carbon alone, right? And then the chemists started looking for reasons why you have so many carbon compounds. And they came up with 2 properties. I'm pretty sure you know that. Okay, carbon. What are the 2 properties?
Catenation
and... Okay, what's catenation?
Ability to form
by itself. Okay, why is it that carbon can form that? It's having a valency 4. Okay, so everything in this group has a valency 4, but why only carbon? Have you ever asked that question? You said tetravalency. Is carbon the only thing that has tetravalency? No. So what about carbon, silicon, germanium, indium, thallium? Is that the group? Yeah. So what about all those? Why? No, it's tin and lead. Sorry, carbon, silicon, valency. But why do they not form carbons like this? Any idea? Okay, I'll tell you. One main property is carbon small. Carbon small, so the nucleus is closer and it can attract so many things. These all cannot do that. One thing. And silicon also forms bonds on itself. You can see silicon doing this. But the thing with silicon is all of these, it's a little beyond your level, but all I'm saying is, as a student learning this, you should have asked this question. Carbon is not the only thing that has tetravalency, right? And it's because these have other, apart from these 2, they have more space. They're bigger. So as an element gets bigger, it has more space in different forms to accommodate other electrons. And that is why this happens. And bigger the molecule, harder it is to form longer chains. That's just simple logic. Okay, you don't have to understand exactly why in terms of chemistry. It's because of some other subshells and all that. And you don't have to learn subshells till next year. So you'll understand it then. But for now, just think of it like these are all bigger comparatively, and bigger it is, it's harder for it to form bonds around itself and make a longer compound. Now another speciality is that the carbon forms bonds with itself. Other compounds also forms bonds with itself. Which one?
Hydrogen.
Hydrogen can form H2, oxygen can form H2, that's true. But the problem is their valency is always less than 3, right? So they cannot form bonds with more than 1, 2, or at most 3 other molecules. But carbon has a valency of 4, which is the highest valency. See, it's either +1, +2, +3, or -3, -2, -1. This one is always 4. It's the highest number. So when I make this graph, this is where carbon sits. That's why. Okay? So one carbon can form these many bonds. So one carbon can form bonds with 4 other carbons, which can form bonds with 3 more other. So it will become a big structure. That's the specialty of carbon. If I also do this with oxygen, one oxygen at most can only form bonds with 2. So see now, even though I used 1, 2, 3, 4, 5 oxygens here, this bonding is not as long as what I made with carbon. See, these many carbons can be formed in a small number of bonds. Okay. Now saturation and unsaturation. So when carbon forms bonds with itself, it can form either a
Saturation.
so single bond, double bond, or a triple bond. Yes. Why are 4 bonds not possible?
Having valency.
Valency is 4. So yes, this is technically possible, but this has a hindrance because of large amount of energy. Every bond means energy. So this is physically not possible. Theoretically it's possible, but practically not possible to have a compound like this. So can I have this? Even theoretically, is this possible? Why? You only have 4 electrons, so you cannot bring in a new one. So most of the time, this is the highest to which it can go. But obviously, when it only shares, here it's only having 6, right? So it needs 2 more. So it obviously forms bonds with something else. Can be anything. So single bond, double bond, triple bond. So this is saturated. Just think of it like it's normal. This isn't. So this is unsaturated. Yeah. So that's basically it. And now other ways carbon can form is chains, rings, and everything. So you can have more than one double bond. So this will make a difference whether the compound looks like this or whether the compound looks like this makes a difference. Is this different?
No. Yeah.
Are these 3 compounds different or any same or? Okay, 1, 2, 3.
2 are same.
2 are same. Which 2 are same?
The first one is
First one. Okay, how is it same?
because it starts from 1.
Yes.
The other one also from 1.
Exactly. You've learned nomenclature, right? So which one is carbon 1 for this one? Which is carbon number 1?
Yeah, that.
This one.
Yeah.
This one is carbon number 1.
Yeah, we can go.
We can put this one also.
Yeah.
Does it make a difference if I start from here?
No, no, no.
It's the same. For this one, which is number 1, is this number 1?
No.
Why not?
From the
Why not?
last-
Marjana, tell me why not.
Because if it's starting double bond, we need it.
Yes, so the functional group gets the priority. So that you need to try and put the lowest number possible for the double bonds. So yeah, so this one will be carbon number 1. So in that case, this is basically the same element with the same compound. So instead of holding it like this, I'm holding it like this. It's still the same. So you need to be able to tell which one is the same. So if you're a little confused whether if it's same or not, try naming the molecule. And if you name it, you will get the same name if they're the same one, if you know naming properly. Okay. So now it can also form rings like this. this is ring. Okay, that's possible. Now, among two rings, you can have a double bond, or I can have two double bonds. Okay, is this possible?
No.
Why not?
Because
Because
the random was 4.
Yeah, but
It is
did I take out? So say earlier before I put this also bond to a hydrogen, instead I remove the hydrogen and made it a double bond. Technically possible, but theoretically possible, but this is kind of hindered. So it can exist like this. This is how commonly carbons exist. Alternate double bonds in a carbon compound gives it a high stability, very high stability. You'll learn why later, but if you see a carbon compound like this, like with alternate double and single bonds, very, very stable. So give me an example of something that has alternate double bonds. You've learned one compound that has alternate double and single.
Benzene.
Benzene. What's the difference between... Okay, what's your name? Yeah. Nena. Okay, tell me what is the difference between cyclohexane and benzene? You don't know. Okay, someone wants to try? Cyclohexane, not hexane. Hexene. And yes, sit down. So, okay, Elizabeth, can you draw cyclohexane for me? Draw cyclohexane. Okay, same. Come here. Draw benzene for me. No, draw benzene. You don't know how benzene looks like? No, okay, benzene has 6 carbons. Draw. Yeah. Yes. Yes, exactly. So what about hydrogens? Will any of these have hydrogens? Yeah, there'll be a hydrogen there. How many? Okay. Draw the hydrogens too. Look at it properly and draw all the hydrogens. You don't need to know how the structure looks like. All you need to know is that there's alternate double and single bonds and it has 6 carbons. Okay, Elizabeth, try it. Okay, what's hexene? What's hexene? How many carbons does hexene have? Huh? You don't know what's hex? Okay, who can do cyclohexane? Him never. Hexene, how many carbons? Give us a Yes, now tell me what's the formula of benzene from what you know. C6? You're right. No, you learned benzene for today. You don't have to worry about it later. That's how you need to study, okay? You have to try and come up with equations yourself so that you don't have to memorize it. You will know. Okay? Okay. You can do it? Okay. Okay, can everyone draw cyclohexane for me?